we've seen the graphical representation of what we meant by electrical circuit. Now, before we proceed, I'd like us to go into another type of another subtopic in current electricity, which is also very important to us. We have what we call electrical energy and power. We must know what is meant by energy and power. The other, in our subsequent lectures, we've given some definition of what energy and power, but we have to relate it here in what current electricity, because we are still going to make use of it. Now, the last time we said electrical energy is defined as a potential difference between 2 points as the work done when one column of electricity moves from one point to another. That's just it. The work done. We said electrical energy is the work done. That's your work done. When a charge, that's your Q, moves with respect to what? A volt. That's your what? VC. QC. Your Q is your what? Quantity of charge. If you remember. Your V is your what? Voltage. So this is the diagrammatical representation of what? Work done. QV. If you recall, all these formulas must stick into your head. You have to know it. If you recall, Q is what? IT. What is I? Current. What is T? Time. So if you bring in this in here, you have work done equals ITV or IVT, current, voltage, and time. So for work done, and your work done is measured in what? In joules. So that is just the formula of work done. By the time we start choosing our calculations now, you'll be seeing the breakdown. You'll be seeing where work done will be coming in, and current, resistance, like that, Yeah, as we were saying, electrical energy and power. We said the definition is just the movement of charges. We said it's defined as the potential difference. That's the potential difference between 2 points. As the work done, you understand, in joules, when one column of electricity moves from one point to another, and we're giving the this is work done, QV, Q is IT. Bring this in, you have your work done equals VIT. That's just it. So at this point now, we'll be treating some questions as regards all what we've done so far. We'll be having 9 different questions. 9 different questions. Now, we'll start with number 1. Number 1 question. Number 1 question says, 5 ohms resistors are connected in parallel. The equivalent resistance is, that's for number 1, 5 ohm resistors. Because you need to analyze in physics or in science, everything has to be done analytically. It's not something you can just imagine. You have to actually draw it out so that you don't miss it. 5 resistors are connected in what? Parallel. Look at it. It's going to be like this. 1, maybe like this, maybe this way. This. They are connected in parallel, not in series. So this is 5 ohms. 5 ohms. You have to draw it out. 5 ohms. 5 ohms. Then you now bring them to meet at the point. This is just the analysis. This is the 5. Then the last one, 5 ohms. So for you to now calculate, you label this R1, R2, R3, R4, R5. So you just tell me that the total resistance. So what will be total resistance? Remember, in parallel we have your 1 over R1, R total will be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over what? R5. So if you substitute those values in, you're going to have, let's come here, you're going to have 1 over RT equals 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5. That's the 5th one. So you have 1 over RT equals mathematics LCM. You have your 5, you have your 1 plus 1 plus 1 plus 1 plus 1. So from there you have 5 over 5. You have 1 over RT as 1 ohms. So if you return it, you have your total resistance as 1 ohms. That's the answer of that particular question, option A. For number 2 question says 2 resistors. Look at this one. 2 resistors of 10 ohms each connected in series. You also need to draw. Don't want to draw, it's no problem. But for me, I would put some drawing. 10 ohms. They are connected in series. That's why it's on a straight line. Now we now said we'll give a combined resistance of, this one is easy. This is your R1, this is your R2. In your series connection, RT equals R1 plus R2. So from there you have 10 ohms plus 10 ohms. From there you have 20 ohms. Option A. So you can see how easy the whole thing are. Just because you have known the rule, you have known that when you have your resistance in series, this is how you get your total resistance. And when you have your resistance in parallel, this is how it's being obtained. Let's go to number 3. Question 3, which speaks about, we gave us a diagram, and from the diagram there was some statement under it. It said, consider a diagram above. Calculate the overall energy with respect to the resistance in parallel, the current given, and the voltage in the circuit. If you look at it properly, this is the diagram we are looking at. If you have a diagram like this, you have 1 amps, which is the current. Now we now have a resistance. 5 ohms is here. Another one is what? 5 ohms down here. This is 5. Now it's now being connected this way. Now under it we now have a volt of what? 10 volts. We are now told to calculate, we are told to obtain the what? Overall energy. Remember, we said energy. You now recall. Here we say solution. And in physics, whenever you have your solution, you must write out the parameters. Number 1, R1 is what? 5. R2 is also 5. Your voltage is what? 10. And your current, I, is what? 1 amps. So for you to solve that, we will now start by saying, okay, we must get our total resistance. So our total, this is parallel connection, is going to be 1 over R total equals 1 over 5 plus 1 over 5. So that will give you. Now, considering that question, we said we are told to obtain the overall energy. Now, before you obtain any overall energy, you have to look at the question given to you. Now, this question given to me is not just one resistance. We have 2 resistors, 5 and another 5. Number 1, you need to compile them together to have one single resistance. So for you to obtain your one single resistance, you say, you start with your solution. You now tell me that, okay, the resistance are in what? Parallel. So when they are in parallel, what do? 1 over R total will give me 1 over what? 5 plus 1 over 5. So from there you have 1 over R total to give me what? This is 5. That will be 2 over 5. So when you interchange, you have your RT to give you 5 over 2, which is what? 2 over 1 over 2. That has given me my what? Total resistance. Now I'm going for energy. You now recall. What am I recalling? That my energy is same thing as my work done, which is same thing as my what? QIT. From the values we had initially. Now, VIT. You know, we said energy equals work done, which equals QV. So this Q is now being broken down to what? IT. So from there you have EW equals what? Your VIT. Where your what? IT is your what? Q. So from there now, we'll now make sure that all our parameters fit into here for us to now have your total energy. So here now we already have resistance. Resistance is what? 5 over 2 ohms. Mind you have to put ohms for this thing to be correct. 5 over 2 ohms. Now we have our current at 1 amps We also have our volt as what? 10 volts. Now, mind you, for it to now proceed, this is time. Do you have time in the question? For you to actually proceed, you must obtain your time. Time is not found in that question. So, let's just do it this way. Let's assume the time taken is what? 5 seconds. For this analysis to be what? Correct. For you to get a very good destination. So, our time is 5 seconds. Now, from there, you can now input those values. So, from there, you have our work done to be V is 10, VIT. V is my 10, my current is what? 1, then my time is 5. So from there, my what? Work done is 50 joules. You solve that. So you can see, even if your resistance, your total resistance is not being used in the overall, you understand, but you are being expected to what? Collide this resistance as 1, making it this 2.5 or 1/2. So that is question 3. Let's go to question 4. Question 4 says a tungsten bulb. Question 4 now. A tungsten bulb. This is a tungsten bulb. Now it has the filament in between. Now it has a holder. That's the tungsten bulb. Now a tungsten bulb is marked 200 volts. That's the volts. You write in your parameters out. 40 watts.